All right, guys, welcome back again. We're going to talk about orbital notations. It is another form of electron configurations in a way, and it might help you understand electron configurations a little bit better. So we have three rules. We have Aufbau, the Aufbau principle. We have Hund's rule and Pauli's exclusion rule. Or principle, principle. Okay, so these are all on your cheat sheet I gave you the other day when we did electron configurations in class. If you remember from electron configurations in class, we have the S, P, D, and F sublevels. What's really important here is to know that the S can only hold 2 electrons, no matter what level it's in. If it's an S sublevel, it can only hold 2 electrons. The P can only hold 6. The D can hold only 10, and the F can hold 14. Okay, now, if you were in I think first or second period, I think we talked about it, but we didn't count them. We had 2 extras on there, so I'll tell you in class on that one. But let me go ahead and put this down. Here's how the orbital notation goes. It's basically a drawing, okay? So we're going to start down here. We have 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and it should all be in one line, but I'm going to have to put it down here because I'm running out of room. Then we have the 5s, the 4d, and the 5p. When we're not going to go into the 6 and the 7 unless we get in class and have to do it, because that's when we get into the F orbital sublevel, and we're not going to do that right now. Okay, so here's what we have. Okay, first thing we're going to do is Aufbau principle. Aufbau principle says that you fill up from the lowest main energy level to highest. So what that means is the 1s level has to be filled before we can put anything in the 2s level. The 2s has to be filled before we can go to 2p. 2p has to be filled before we go to 3s, and so on. Okay. The Hund's rule says that here's how, and this is the only way I can really describe it. You have to fill up every orbital with 1 before you get another. So I think of it like this: everybody gets their own room before they get a roommate. Okay. So fill orbitals in sublevels with 1 before doubled. Okay? Now, the last thing that we have to know is Pauli's exclusion principle. That says that we have opposite spins. So electrons spin in opposite directions. Opposite directions, okay? So we do this by showing arrows. Okay? We use up and down arrows. What Pauli says is that one arrow has to go up, one has to go down, because the electrons have to spin in opposite directions. If they didn't, they'd run into each other. They don't like each other. They like their space. They don't like anybody. They just like to be out by themselves, so they go in opposite directions, so they never hit each other. Okay? So let's see what this looks like in a diagram. I'm going to give you, let's say we have, let's do carbon first. Carbon. Carbon has 6 electrons. Okay. So what we have to do is we have to start with alpha. We have to start filling up the 1s level first. So I do 1 up, and then I have to go 1 down. That's Pauli's. Hund's rule, we don't have to worry about it here yet, but only because we have this so far. Then we have S. We go up, then down. I'm going to have you always start with an up arrow and then a down arrow. So always go up arrows, then down arrows. Okay, just be consistent. You won't make any mistakes. So then we have 4 electrons counted. 1, 2, 3, 4. We still need 2 more. So we're in the P. So we have up and then up. These little dashes are what I'm talking about for Hund's rule. If you notice, the P will hold 6 electrons. Each little dash or box will hold 2. Those are your rooms. Remember I told you fill up the orbitals first? Those are your orbitals. Fill up each room before you get a partner, before you get a double. Okay? So it would be up, 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 down, down, down after that. But we only need 6, so we stop there. Now, if you want to do the electron configuration from your orbital notation, you have a 1s2, 2s2, 2p2. That's what remember that was our final address, per se, for carbon. Okay, let's do another one. Let me get this one. See if I can erase this real quick. We'll do aluminum next. What you're going to do is find aluminum on your periodic table, and you'll see that aluminum has 13 electrons. I'm going to leave that parentheses there. We normally do not have any parentheses there, but just for our purposes, I am going to use the parentheses to kind of show you where the break is between, because my board is kind of small that I'm using, and I run out of room fast. Okay, so we're going to do aluminum, and it has 13 electrons. So each arrow represents an electron. We start with alpha. We fill up the lowest energy level first and sublevel, then the next energy level and sublevel, and so on and so on. Hund's rule: fill up each sublevel with 1 before you double up. Give each one of an opposite spin, so that's the up and down arrow. So we're going to go 1, 2, 3, 4, up, down, up, down. Why? Because this s orbital can only hold 2. Up and down is all you need for s orbitals. P, you have to give each line, which is an orbital, 1 before you double up. So we're at 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's the s orbital again. 13. Okay. If you notice, we have 2, 4, 6 in this P level. This one's not full, so it's okay. So 2, 4, 6, 8, 10, 11, 12, 13. So if you remember, our configuration is 1s2, 2s2, 2p6, 3s2, 3p1, 2, 4, 10, 12, 13. Okay? And if you remember, this is where we would end up. If you put your finger on it, you know the final address. Okay? The ending of the address. Let's do one more that's a little bit longer. And I'm going to get rid of this real quick. And again, we don't usually put the parentheses there. I just put them there just because my dashes are a little bit too close together. Okay? My dashes are a little close together, so I'm trying to not cause any problems between what you understand and what I've done. Okay? Let me get this one. Let me redo 2 because this one's a little bit off. The 2p level has 3 orbitals in it. That's why it can hold 6. The D level can hold 10, so it has 5 orbitals. And P, I'm putting parentheses here. They normally do not have them. I'm just, like I said, I'm just putting them on there so you can see where the break is, okay? So let's go ahead and we're going to do, instead of aluminum this time, let's do arsenic, like what we did, what was in our other videos. Let me erase this real quick. And if you remember, arsenic has 33 electrons. It's going to end in a 4p3. Is the if you look on the periodic table, it ends in 4p3. So remember, we got to count for every electron. So we're drawing out the orbital notation. It goes up, down, 2, up, down, S2. Sorry, up, up, up. Fill up each one before you give it a down arrow. Down, down, down. Okay. Opposite spins. 2, 4, 6, 8, 10. Noble gas would start right. Noble gas would be right here. That would be neon. Okay. Then you have an S. Up, down. Just 2 go in there. The P. Up, up, up. Down, down, down. Do we have 33? 2, 4, 6, 8, 10, 12, 14, 16, 18. Noble gas right here. Up, down. Okay. If you notice, it's 4p, but what's in between? 3d. Okay. And you know why? 2, 4, 6, 8, 10, 12, 14, 16, 17, 18, 20. We're not at 33 yet. But again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everybody got one before we moved on, and they're in opposite spins. Okay, there's 10 here. D holds 10. See, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 24, 26, 28, 30, 31, 32, 33. 4p, 1, 2, 3. Okay. All right, so we're going to do some more of this in class, but just remember these 3 rules. Remember how many can go in each orbital, sublevel. When you do these, you'll actually have these markings on there. You won't have to put them on there, or there'll be boxes, okay? So I think you'll find it easier, and then it'll tie in how to do electron configurations and noble gas configurations better. I'll see you on the next video. Hopefully this recorded. At least it's on.